quadratic function is a function in the form of ax squared plus bx plus c. A doesn't equal 0. Any of those other numbers can be 0, but a can't be 0. So we've got, for a quadratic function, we have an x squared now. Okay? That's what makes it curved. Without that x squared, we just have a slanted line. Once we get the x squared in there, it starts curving. Send it back.
Don't send it back anymore.
Don't send it back. I mean, already again. Right. And I don't know. The domain of a quadratic function is all real numbers. I can put anything I want into this function. I'm not necessarily going to get anything back out, but anything can go in. There are no restrictions on the domain. Whatever you want here. You might remember, you remember what these are shaped like, right? No? You get the shape, the parent function. I'm trying really hard to write on this without it going crazy. Oh, the squeaking. Yes, makes my ears bleed by the end of the day.
First time you go.
That's the parent. And that's just a plain old parabola that we haven't done anything to, we haven't messed with it. I think I'm graphic here today. Like that. That's the parent function right there. If you think about it, you got 0 squared is 0. 1 squared is 1. 2 squared would be 4. And then over here, negative 1 squared would still be 1. Negative 2 squared would still be 4. So, it would be a positive 9. So you square it, takes away the negative, right? Okay, so that's the parent. And then just like yesterday, or the day before, when we did the absolute value function, you can move these around also. We had f of x equals x plus 1 squared plus 3. That would basically take that parabola, this one right here, move it left 1, up 3. And we do the same shape, and we just move it over. Just like the absolute values. What was that, Monday? Yeah, Monday. If you put a negative in front of it, that negative is going to flip it. That would look exactly like the black one, except flipped over. call this one standard form. I will always call this standard form. Okay? Some people call this general form. I do not call it. Your book calls it general form. Everyone else in the world calls this standard form. And then the other form they call standard, but it's actually vertex form. Then in a minute they change it to vertex form. And it is with the H and K that we were talking about, how you move it around. We're going to call that one vertex. A times x minus h squared plus k. We've already talked about what h and k do. Can y'all see that board, or do I still block it? Does this help? No. No? Is that good? Okay. I'm trying to not say no, but like I'm always in the way. Alright. So this one's called vertex form because that's your vertex. H, K is your vertex. Like, on this one that we just did, we moved it to negative 1, 3. See, there's a vertex, that's negative 1, 3, right there. So, that's why this is called vertex form, because when it's like this, when it's like this, that's your vertex right there. Negative 1, 3. H, K. Because it's in parentheses, you can change the sign. It's kind of opposite thing. I'm going to let you try to find the vertex on a couple of. Do you remember completing the square from last year? We're going to take a pause and learn how to complete the square. What's the vertex without parabola? Yes. Negative 6, negative 4. Yeah. Negative 6, negative 4. Exactly. So if I needed to graph this, okay, I could start at, here. And, you know, parabolas, they are mirror images, right? Either side. They've got this line that goes through them, through the vertex, called the axis of symmetry. And I can cut it in half on that line, and it'll match on either side. Okay? So if I need to graph this, I've got the vertex right here. Right? So, if I'm just sketching, I can just pick a point on this side and put that in and see where the other point is. So this is at negative 6. So we can pick another point. What point do you want? 3? Positive 3?
No,
negative 3? Okay. So 2 times negative 3 plus 6 squared minus 4. It's going to be 2 times 3. That's just 3 squared minus 4. So 2 times, okay. So 3 squared is 9. So 2 times 9 is 18. And 18 minus 4 is 14. So at negative 3, I'm way up here at 14. So see how this one is 1, 2, 3 spaces over? Well, up here, it's going to be another point, 1, 2, 3 spaces over. So I could sketch this parabola. Whoop, I'm in this. Hang on. There we go. Just like that. Okay? It's pretty easy. Pretty easy. Okay. So let's look at one of those. So, let's say we got wait, let's change colors. I'm tired of the green. This is purple. That's my favorite. I like to get up sunlight. 10 purple. Alright, f of x equals negative x squared plus 2x plus 4. Alright, so you have to graph from general form or standard form, what I call standard form. A really great thing about standard form is right away you have your y-intercept. Right away. Anybody know what the y-intercept is on this one? It is, yes. And how do you know it's 4? The last number, because what's going to happen when I put a 0 in for those x's? Yeah, they're going to go away automatically. So I always start with my y-intercept. 4. You write some steps down. Start with y. Intercept.
And let's say you had like plus 4 minus 2 would be 2.
Yeah, whatever the constant is. So I start with the y-intercept, and then I get my axis of symmetry. Which is that line that goes down the middle of whatever. Axis of symmetry is really long. Okay, AOS. And your axis of symmetry is at negative b over 2 times a. This is a, this is b, this is c. Okay, so we're going to have a negative 2 over 2 times negative 1. You already see where all those numbers came from and why they're there. Where did the negative 2 come from?
The negative b.
Right. See, b is 2, and the formula says make it a negative. So it's negative 2 over 2 times a. A is negative 1. There's not a 1 there. We don't write 1, but it is negative, so it's negative 1. What's negative 2 divided by 2 times negative 1? 1. It's 1. Okay? So I have an axis of symmetry at the line x equals 1. I think I have this little trick on here. I'll make a dotted line. Let's just see. So good. Alright. So I don't know much right now, okay? But I know that this is the axis of symmetry. There's a point there. There's another point right here because that's a mirror image, right? There's one more really important point that I need. Does everybody know what it is?
Vertex.
I need the vertex. Yes. Okay. So the vertex sits on the axis of symmetry. It's on this line. So I know what the x is going to be. I just need to figure out what the y is going to be. How can I figure out what the y is going to be if I know what the x is? Over here. Yes. You are on fire. You need to run 10 miles every day
No.
in class.
No.
So the third thing I need to do is find a vertex. So I'm going to see what happens when I put that axis of symmetry in. You can put that in your calculator just like that, just like it looks. I'm going to get negative 1 plus 2 is 1. 5.
Oh yeah, because the negative is
Because
the
that's a
outside.
negative. Yep. So it's at 1, 5. So it's just one more up.
It goes down.
How did I know it's going to open down before I even
So the
grab it?
negative in the outside.
Is that negative A right there? Exactly. So it's not difficult. Neither of them are difficult. This one is a little bit more time consuming, but it's not difficult math that you have to do. It's time consuming math. It's going to eat up a little bit more paper. So we'll plant a tree, okay, at some point. Arbor Day's coming up. We'll plant some trees.
Arbor Day. Arbor Day.
Arbor Day, yeah. Every day's Arbor Day. Anyway. Oh yeah, so this just takes up some more paper. It's not difficult. Let's look at this one more time. What did we do on this one?
You
We started
with the vertex.
with the vertex, okay? Because it's given to you. That's vertex form. It gives you the vertex. That's why we call it that, okay? It's vertex form. So we started with the vertex. I drew in my axis of symmetry. And then what did I do after I had that? Started with the vertex. Then I picked a point.
Right.
I picked a point. To here. We both have 3 steps. Just one of the 3 steps is easier than the other 3 steps. Or less time consuming. They won't all be like this.
It could though.
So, let me give you a little practice. Here's the thing. Right now, until I remind you how to do completing the square,
Well, I don't know what it is though.
yeah, well, it gets you from this form to that form. So until I remind you how to do that, some of this stuff we're not going to be able to do. You have to, if one to go from one to the other. So, how about I'm just going to give you a couple to practice graphs, okay? And I'm going to make them up, and I'm going to try not to make up, like, just ridiculous ones. Alright, let's see. Oh, I'll give you easy. How about this one? This is easy. X equals here. That one doesn't even have a D. How about that? You're welcome. Alright, graph. Okay, so this is standard form. Start with the y-intercept, which is C. So what's the y-intercept on this? 1, right? Okay. This is a really easy one, huh? What's the axis of symmetry? What's B? There's no B, right? So your axis of symmetry is a negative 0 over 2 times 1. Well, what's 0 over 2? Nothing. 0. My axis of symmetry is actually So it's got a little buddy over here. Don't these look like deer to me, like on Christmas, like reindeer? Does anybody else see that? Like, doesn't that look like Rudolph to me? I only done this like, I don't know, 100 years, and they always look like Rudolph to me. Anyway. Lunch in here yesterday. Alright, what's the vertex on this one? Okay, 4, 2. So that's going to be is that the uppermost point or the lowermost point?
Lower.
That's the lowest. This one opens up. Alright, so I got the vertex. There's an axis of symmetry that passes through that. So what point did you pick to put in? Okay, this point. 2. Alright, so 2 minus 4 squared plus 2. That's going to be a negative 2 squared. It's going to be 4 plus 2 is 6. So 2, 2, 6, there's a point. That one's 2 away. It's got a little buddy over here that's 2 away. You missed it. There you go. There's a little reindeer. That's pretty easy. Time consuming, but it's difficult. There's a difference. Okay? Don't confuse difficult with time consuming. Alright,
Once we did 0, so it would be 0 plus 2.
did we do these last year? I think. You did 0. You did 0. Yeah, 0 minus 4.
Oh yeah, that's right.
Yeah.
No, I mean not 0, 4, positive 4.
Oh, that would have been good. Yeah. That would have been easy. Yeah. Oh, you can't do 4 though, because it's on 4, 2. That's your birthday.
Oh yeah.
Gotta be 1 time in. We did do these last year. We're gonna do more stuff in them this year, but we did do this some last year.